So we're looking at finding the area under a normal curve. And what we did so far was we used the empirical rule. And that was that 68, 95, 99.7% rule. But we know that when we did that, we had to memorize the rule. And then it became hard. We had to go through and figure out what the little strips were. And if we didn't land on a specific strip, we wouldn't know what to do. So what we're going to do now is we're going to use the CDF function on our calculator, and we're going to have it do that. So you want to have a calculator for this part, okay? You can also do this using z-tables, and when you get your SOL, the formula sheet will have this huge table on it, but we're just going to deal with the calculator and not deal with the table because it's easier, okay? Okay, so problem 1 is a corn chip factory. It says a corn chip factory packs chips in a bag with normally distributed weights where the mean is 12.4 ounces. So that's mu is 12.4. And the standard deviation is 0.15. Okay. So first we're going to do just like we would do for any other problems. We're going to start out and we're going to label our graph. So our mean is 12.4. Mark 3 above. So again, when I put my third mark on, I'd put my third mark over there in like the very tails of the graph, and then just sort of sneak the other 2 marks in between. Okay. And then we've got to go through and we've got to add our 0.15 to that. So if I take 12.4 and I add 0.15, that's what, 12.55? So if I add it again, I've got 12.7. And if I add it again, it's 12.85. Or I could go backwards. So that would be 12.25. Or again, 12.10. Or again, 11.95. Okay, then number 2 says to shade the region that indicates the bags that contain less than 12.64 ounces. So the problems we did last time, 12.64 would have had to been on one of these standard deviation marks in order to use our rule, but it's not. 12.64 is somewhere in here, right? So we can't just use our 68, 95, 99.7% rule because it doesn't fall exactly on the standard deviation. And we want less than, so we're going to shade to the left. I think it's always a good idea when I'm doing these to think, should my answer be big or should my answer be small? And I can look at this graph and say that most of the graph is shaded. So I should realize that if I get an answer for how much this is, it should be most of the material. All right, so number 3 says use your calculator's normal CDF. The C is really important. Your calculator has 2 functions, a CDF and a PDF, and you always want the one with the C, okay? To find the area shaded in number 2 and state the percentage of bags that contain less than 12.4 or 64 ounces. So you want to be sure you give the answer as a percent, not as a probability or a decimal. Okay, so in my calculator, if I'm using the Casio, I need to go to menu and I go over to number 2 for statistics. This is a normal distribution. So I hit F5 for distribution. And then I hit F1 for normal. And that's where it is, NCD. Okay. And that pulls up this list and asks me my lower, my upper, my sigma, and my mu. If I'm using my TI, unfortunately my TI on the screen doesn't look the same as your TI that has the pretty print. Like where it makes the exponent small, it makes fraction, it makes the square root symbol long. So on this one, distributions is right here above vars. So I hit second, and then I go to distribution, and I go down to normal CDF. I have to choose the one with the C. Oh, my board just died. So on the Pretty Print TIs, when you hit the button, it'll come up with a menu like we have on the Casio. You just have to be careful because on my Casio, the sigma's on the top and then the mu, and on the TI, the mu is on the top and then the sigma. So just be careful if you're paying attention to that, of which one you're doing. And some of the Casios up at the top, they have a thing that says variable, and you can just leave that as variable for the data. Okay? So what we need to do is we need to put in a lower and an upper, and these are the bounds for our graph. Our upper bound is the 12.64. But the lower bound, I need to think about, there is no left side where I capped it off. This goes to the left forever down here. So for my lower, I need to put in the smallest or most negative number I can think of. So what I like to type is I type a negative, and then I just keep typing a whole bunch of nines because I think that's the smallest thing I could possibly type into my calculator. So negative, keep hitting nines until the screen fills up, and then hit enter. Okay. I turned it into scientific notation. You could put 0 and it probably would work fine for this problem, but in some problems you can go negative, so it's just a good habit to put in a really negative number for your lower if there is no lower. Then we're going to go down and we got to put in the standard deviation and the mean. So my standard deviation was 0.15 and my mean was 12.4. Again, if you had a TI, those two were in different orders. Mine has this save residual thing. You're just going to skip that. Go down to execute, and you can hit enter, and it gives you the answer right here. It says P is 0.94952. So P 0.9452. So that's a probability. What I was supposed to answer wasn't a probability, but it was a percent. So to convert it to a percent, I'm just going to move the decimal over 2, and my answer is 94.52%. Back in the beginning of the problem, we said this looks like most of the graph, so our answer should be pretty big, and 94.52% is pretty big. The TI gives you the same thing, it just tells you the P. The other thing that's on here are these z-scores. I don't know if you remember doing z-scores in Algebra 1, but there was a formula for doing z-scores, and that was converting things over to that standard normal curve, which was the first thing we did where the mean was 0 and the standard deviation was 1. So we don't need to worry about the z-scores. You need them if you're using the table. All right, so on number 4, we're supposed to label and shade the region that represents the likelihood that we're going to be between 12.1 and 12.76 ounces. So again, the 12.4 was the middle. If I'm looking at my scale that I had up there, 12.1, that was right on a standard deviation. But the 12.76 was not. That'd be way up here. And I want the amount in between. I'm looking for the probability that I'm between. So my answer needs to be a decimal. And I know that this is a pretty high probability because most of the picture is shaded, right? So I'm just going to go right in my calculator again. And if you still have it up there, you're good to go. Just exit back. In this case, my lower was the left side, which I had a left stopping point. So I'm going to enter the 12.1 for that. And my upper was the 12.76 because I had a stopping point for that. The mean and the standard deviation didn't change, so I don't have to re-enter them. I just go down and hit execute, and it tells me the probability is 0.9690. So I truncated. So I went out 4 places and then I just chopped. Either way, if you wanted to round it, you could, but if you go out 4 places after the decimal and chop, then that's going to be accurate enough. There's never going to be the choice between two things that were that close together. Okay? So in the next question, we're still dealing with the same amount, but now we say we're going to order 375 bags of chips, and we want to know how many bags of chips would you expect to contain this between 12.1 and 12.76. So our probability that we just got in the last question was the 0.9690. That's the probability that I'm there times the 375 bags of chips. So for that, I would want to be in my regular run menu on my calculator. Let me get rid of the marks. So I'm going to go back to the regular run menu. And I'm going to multiply. So I've got 363.75 bags of chips. Can I have 0.75 of a bag of chips? No. 0.375, thank you. So either way, I can't have a portion of a bag of chips. For some things, you can have a portion of something. Like if we wanted to know how many pounds of potatoes to order, we can order a portion of that. But for bags of chips, I would probably round this to 363 bags. Again, if you had rounded up or down, it probably wouldn't have made a difference in the question. We're not usually that particular. But we should have a whole number of bags of chips. Okay, so the second problem is about unicorn horns. We've got a herd of 972 adult unicorns, and the lengths of the horns are normally distributed. We have a mean of 10.1 and a standard deviation of 1.04. And we're going to label this graph just like we normally would. So I got my middle, and I'm going to label 3 marks above and 3 marks below. And then I'm just going to use my calculator to figure out what those are. Okay, so number 2 says, on the graph at the right, shade the region that represents the probability that a unicorn's horn is being longer than 9 centimeters. And we want to calculate the area of that region, which is the probability, using our calculator. So where was 9? 9 was right about here-ish. And it needs to be longer than 9. So longer than 9 would be shading to the right over here. Okay. So in my calculator, I got to go in the stat menu if I'm on my Casio. And then I went to F5 for distribution, F1 for normal, and I hit NCD. I have to do the cumulative one because it's a whole shaded area. So for this one, my lower is my left side, which is going to be 9. And then my upper, this is going forever to the right. So my upper needs to be the biggest number I can think of. So what's the biggest number I could type into my calculator is 9. And I'm going to just keep filling the screen with 9s until I run out of space. And I'm going to call that my upper bound. Okay, so I just fixed the scale up here because my class told me that I subtracted wrong. So we got that fixed now, and those are really the right numbers. I do need on my calculator to still fix the standard deviation and the mean. For this problem, the standard deviation was 1.04. And the mean was 10.1. Remember, if you have a TI, that the mean and the standard deviation come in a different order. And I can see my probability is 0.8549. So this one asked for the area, and the area is the same thing as the probability. So on A, it asks you what's the probability. That's going to be the exact same thing. the 0.8549. In part B, it says how many unicorns should have a horn longer than 9 centimeters. And back in the beginning of the problem, they told us there were 972 of them in the herd. And we're going to multiply that by the 0.8549. So I'd go back into the regular run menu. And 830.9628. So in this one, I would probably round that up to 831, but you can't have 0.9 of a unicorn. Okay, so on number 3, on this one, it says shade the region that represents the probability of a unicorn's horn being longer than 10.5. So from 10.5, I could go up, or less than 9.5. So from 9.5, I can shade down, but I'm not in between two sections. And what my calculator gave me was the probability that I was in between two sections. So we have a couple of options for how we could figure it out. We could either find the blue area and the green area separately and then add them up, or we could find the white area and subtract it from the total. I think most of you guys would find the two areas separately and then add them up. Even though that takes a little longer, that's just the way you guys usually do it. All right, so we're going to go back to our stat. And let's go ahead and try and find the blue area and the green area. And I'll pause the video while you try that now if you're at home. And then we'll see how you did. So for the blue one, I used a lower of negative 9999999 and an upper of 9.5. And that gave me my probability of 0.2819. And then for my green one, I used a lower of 10.5 and the upper of a whole bunch of 9s. And that gave me 0.3502. And I added them together for a total probability or area of the 0.6321. All right, so for part A, it says what percent of unicorns. So we're going to move the decimal place over 2. So that's 63.21%. And then part B says of the herd, how many? So remember we had 972 in the herd. And the probability was the 0.6 number. So when I multiply, I get 614.4, but I can't have 0.4 of a unicorn. So I'm going to call it 614. All right, on number 4, in order for the unicorn to be in the parade, her horn must be in the 75th percentile. So that's a new word, percentiles, and that means that 75% of the unicorns must have horns that are shorter than hers. So if you're 75th percentile, that means 75% of people are below you. So you're in the top portion of the information. So if we want to be 50th percentile, that'd be right smack in the middle, this would be 50th percentile. So if I want to be 75th percentile, I'm going to be somewhere up here-ish. But I've got to now work backwards to figure out where is this mark? How many centimeters long is the horn? So I'm going backwards. So you go to the same place as you would to do a normal distribution. So you go to menu and we go into stat. We go to distribution, we go to normal. But there was another option, and it was inverse normal. So that's the one that we're going to do. If you were using your TI, when we went to distribution, let me clear that out. When we went to distribution, if you go down underneath normal CD was inverse normal. So it's the same thing in that one. So long as you got the pretty print, it'll pop up a menu like ours does. Okay. All right, so the next thing it asks us for the tail part is the tail on the left or the right. The typical way we do these is when the tail is on the left, that's what it is for a percentile, but you can change that back and forth. The area for us would be 0.75. That's the same thing as the probability. So it could ask us for either the area or the probability, and we need that to be 0.75. And the mean and the standard deviation were still left in there from the last problem, so I don't need to change that. And then when I go down and solve it, it tells me that x is 10.8. So 10.8014. And we should realize to be in the 75th percentile, we need to be above average. Average was 10.1. So 10.8 seems like a realistic answer. Always check to be sure you're making a realistic answer. So 10.8 centimeters would be the length of the horn, and that was the inverse because you're just going the opposite direction. Okay, so just to emphasize what this means is if I started and I was working forward and I wanted to find the percentile, if my lower was negative 99999 and my upper was this 10.8 centimeters long, and I calculate the probability, the probability I get is 0.74999 or 0.75 or 75%, which was the percent of people that were below, or unicorns that were below this one.